The goal of problem number 4 is we want to determine the molar mass of our compound. And we know, of X in our compound. We're determining the molar mass of X. And if you can remember, the units for molar mass of X are going to be grams of X over moles of X. These grams of X are going to be determined indirectly by assuming we have 100 grams of our aluminum compound. Okay, so we're going to determine what our grams of X are indirectly. If we have 100 grams of our aluminum compound and we subtract that by the 18.56 grams of aluminum, we're left with 81.44 grams of X. And according to the chemical formula of our compound, for every 2 moles of aluminum, there are 3 moles of X. Okay, so our pathway for solving this problem is we're going to go from grams of aluminum to moles of aluminum to moles of X. Okay, so we're going to start off with what we have. We have 18.56 grams of aluminum. And we're going to convert that to moles by dividing by the molar mass. We have 26.98 grams of aluminum for every 1 mole of aluminum. And the mole to mole ratio is that we have 2 moles of aluminum for every 3 moles of X. So that gives us 1.0319 moles of X. Okay, so we have our grams of X, which we solve for by subtracting 100 grams. Subtracting 100 grams minus the 18.56 grams of aluminum, so that's our numerator. And we have our denominator, which is the moles of X. So if we take 81.44 grams of X divided by 1.0319 moles of X, our answer ends up being 79 grams per mole. Okay, so if we look at why we have it to 2 sig figs, is because when we subtract, we are going to end up with, to the lowest decimal place, 81 as a significant figure. And if it's just going to have 2 sig figs divided by 5 sig figs, our answer will only be reported to 2 sig figs. So the molar mass of our element is 79 grams per mole. In this next problem, we want to determine what our energy X is. The first step in solving this problem is we want to write down the balanced chemical equation. So in this problem, we have iron reacting with chlorine to produce a compound with iron and chlorine in it. And we're also given that we have 75 grams of our iron and 170.2 grams of our iron chloride compound. We can determine the amount of chlorine by taking 170.2 grams of our compound minus the 75 grams of iron. That will give us 95.2 grams of chlorine. So if we have our grams of iron, we have our grams of chlorine, we can solve for the moles of each, divide by the smallest number of moles to get the empirical formula. We have 75 grams of iron. If we divide by the molar mass, we'll get moles of iron. So this ends up being 1.34 moles of iron. I have 95.2 grams of chlorine. If I divide by 35.45 grams of chlorine per 1 mole, this ends up being 2.69 moles of chlorine. And so this is what I have. I have iron, I have chlorine. I'm going to divide by the smallest number of moles, which is 1.34. And what we'll end up with is FeCl2. X is equal to 2. If we write out the balanced chemical equation, you end up with iron plus chlorine produces iron 2 chloride.